model that describe how the client, oops, how the client and the servers interact each other. Yeah, the idea is as follows. The client is always sending messages, is always making questions to the server, and the server take this question, take these messages, try to read it and try to answer it and send back a message to the client with a response. So the idea is the client is always making requests and the server always is gonna try to respond to this request. This is the cycle. And the way that the client and the server interact each other is through a web REST API. This is the main of communication that the client and the server have. If we try to analyze, try to put this concept into Earth Engine context, the idea is as follows. As all of us as a clients, we use a client library, and the main function of the client library is transform, in this case, a JavaScript code into a JSON file like this, a petition like this. So it's important. It's really important that you understand that the main function of a client library, it's transform, in this case, is the JavaScript client library, transform this piece of code into a JSON petition like this. And the web REST API is gonna help us to send this JSON petition to the server. The server is gonna try to respond this this request and gonna be sent back the response to the client. And yeah, this is a cycle in that we use in Google Earth Engine. What is important to understand is because right now Google just support two client libraries for two different languages. The first one is JavaScript and the second one is Python. So what we so yeah, if we want to create a client library for any other language, we need to see a way to try to solve this first step. You know, if you are interested in create an R client library, you will have to try to search a way to transform the R code into a message like this. If you are interested in other language like Julia or MATLAB, um, yeah, you need to see a way to transform the MATLAB code or the Julia code into a petition JSON file like this. That is the idea. And yeah, that is how does rgee currently works. And the previous slide is this part, this red box. Here we have the client, the client library. We have here the web REST API and the server. So to make that RGE could work, to make a client library for R, we add a previous step to the Python client library. And the idea here is we use reticulate, and reticulate is an R package that permits you embed a Python session into an R session. And we use reticulate to transform R code into Python code. This is the previous step that I mentioned. And after that, it's just going to follow the same path. This is the full overview of how RGE works. We use reticulate, as I mentioned, to transform our R code into Python. And after that, we are going to use the Python client library that is supported by Google to transform this Python code into a JSON file. And this JSON file is sent to the server, the green one part of this, using the web REST API. That is, in a nutshell, how RGE works. We use Reticulate just to virtualize a Python session within an R session. And honestly, this is not a big deal because Reticulate, RStudio created this package and made a really amazing work to transform R code into Python code. It's just a question of a few lines of code. And so maybe you asking yourself why RGE takes so long time to develop. And the answer to this question is that we worked several months to try to integrate better the server objects, the server classes modules that Google Earth Engine offers us we integrate this with the R spatial ecosystem. So yeah, that is our principal work in RGE. Make everything more smoother, the local objects with the server objects. And also we work a lot in the IO. Try to make even simpler the download and outload of images and vectors between R, the local environment, and Google Earth Engine, the server environment. And here are just two questions that always people ask me. And the first one, it's about if all the functionality of Google Earth Engine of the Python client library is also available in RGE. And the answer to this question is yes, because you need to remember that we use reticulate and reticulate embedding a Python session into an R session. So yes, all the classes, all the models, and all the functions are available. And the other question is about if RGE is gonna be slower in comparison to the Air Engine Python API. And unless in the experiments and in my experience, I never have any problem with the speed. And in my opinion, unless RGE is as fast as JavaScript or the Python client libraries. But um, if you disagree with this, yeah, please let me know. I will be really happy to hear about problems with the speed related with RGE and the Python client library. But I never found any of this problem. But if you have it, please let me know, and maybe we can try to fix it with some way. So it was just an introduction about RGE, and now please let me introduce you some of the main features that we offers with RGE. And the first one, and I feel really proud about that, it's our work in the input and output, because it always, for me at least at the beginning when I was starting using I would start using this new platform. For me, it be a bit complicated to search automatically ways to download or move a server object like an image to my local environment. For instance, in this case, in this specific case, move an image and convert it into a raster stack. Probably people that use R a lot can understand me. R stack is an object inside the raster package. So in Python, unfortunately, in Google Earth Engine, we just have functions for to move um, this image to intermediate containers like Google Drive and Google Cloud Storage. And if I want to move this image from Google Drive to our local environment, we need to develop some kind of function. Yep, that's the problem. And we try to make everything simpler in RGE, and we create this function image to drive that makes exactly the same that this other one that is available in Python and also available in R, obviously. But we change the name just to make more R syntax friendly. That's in but both functions at the end do the same. And this is a function that we develop. It's EE drive to local. And this function is going to permit me to move an image from Google Drive to my local environment. This is what we call the RGE low level API. But also we develop a high level API. And with this high level API, we can move an image from the server side to our local to the local side with just line of code. In this case, if we want to move an image to and convert it into a raster stack, I can use EE as raster. And please, I have a really short example to explain this. And to use RGE is so simple. You just need to, it's almost the same that Python. You just to initialize first your Google Earth Engine session. You can use this function in R, EE initialize, and the line from the line 6 to the line 8, I'm creating an image object, and I'm selected the bands 1, 2, and 3. And if I want to move this image to my local environment, I just need to use EE as raster or EE as a start, depending of your preference. And put here the image and just the scale. if I run this line of code, it automatically, the first thing that this function is gonna do is move the image to your Google Drive, and after that, it's going to move from Google Drive to your local environment with just line of code. That is something great. I think it makes everything simple. Especially if you are trying to download hundred or thousand of different images from Google Earth Engine. The same logic if you are interested in download feature collection, but you need to change EE as raster by EE as SF. That's all. And what about if I'm interested in upload the image? Well, we also have a low-level API and a high-level API, but unfortunately, to upload image to Google Earth Engine, we just have the option to use Google Cloud Storage. So you need to have your service account key in your computer if you are interested in automatically upload images from your local environment to Google Earth Engine. But yeah, it's also just one line of code. If you want to upload images, in this case, geometries from your local environment to Google Earth Engine, you can use SF as EE, or if you are interested in images, just raster as EE. That's the idea. Um, um, yeah, the I/O is not the only functionality that we implemented in RGE. We also have the map environment that try to mimic how the code editor display, the raster service on the fly that Google Earth Engine offers us. For instance, in the code editor in JavaScript, if you want to display an image, you need to use map.add_layers. But in art, you always need to change the dot by the $sign like this. So if you want to display, it's exactly the same. You just need change the dot for the $sign and it's gonna work. In RGE, also implement two different map operator. The first one, the plus, that permit you stack different map in the same view. And the, I don't know, remember the name of this operator. This logical operator is the side-by-side. It's gonna permit you display and compare two maps in a side-by-side view. That's the idea. Yeah, these vertical lines. I don't know the name of the operator. Sorry for that. And yeah, and also another interesting functionality that we implement in Google Earth and in RGE, it's the health display. Yep, let me. Oops, finally it finished. And yeah, as you can see here, we have now we move the image from the server side to our local side with just one line of code, and we can see it here. For instance, I can use map view also for display this image, and yep, and yeah, I put a lower scale for don't take too much time, but yeah, this image is now into a local environment. So yeah, that is the idea. And now, if you are in, yeah, some of the problems that I have with Google Earth Engine in R that I always like to display the documentation, and I think the code editor in Google made a really great work with this IDE. So with RGE, we try to implement something similar, and that is why we implement this function EE help. And if you are an RStudio user, you can also use our add-ins. We create an add-in, and you can modify a keyword to use this add-in automatically. Let me show you how to do that. You just need to go to tools. After that, go here and modify keyword shortcuts. And please search here EE help and put here the shortcut that you prefer. In my case, I prefer to use F3. So I'm gonna put here F3. Just click here in apply. And now, in R, if you want to display the documentation, you just need to press F1, sorry. But if you want to display the documentation of Google Earth Engine methods, classes, and everything in Google Earth Engine, you just need to press F3, and that documentation, it automatically appears in the viewer area. So yeah, this is, I think it's really helpful, because if you are trying to implement random forest model, you just go here, click F3, and all the argument is gonna appear here with the documentation in a very friendly way. So yeah, that is um, the EE help. Yeah, it not just work for method, it also work for modules and classes. So yeah, I think it's really helpful when you start to using Google Earth Engine, and yeah, that is why I mention it. I take advantage of this opportunity just to mention it. And other important point that see that people don't use when use RGE is that RGE right now also support have Py support. And yeah, if you probably using Python or JavaScript, the style to change different methods is throughout a dot. But remember, you need always change the dot in R for the dollar sign. So yeah, I think this is the Python JavaScript style to change different methods. But if you are a Py user like me, you probably want to use also the Pyths. It's also possible to use Python with RGE. And I think, at least in my opinion, it's always better use pipes, principally when you are coding really large scripts, because with pipes, for instance, in this simple script, I try to display the number of bands that this Landsat Edge have. So um, with bytes, I can see the previous result of a process. For instance, in this case, I know that the previous result is an image, is an image, is an image. But now here I see a list, and it's here a list because the previous result is a list. So when I have a really large code, I consider that it is really helpful to see the previous results of a changing process like this. And yeah, it is like an static typing that you can use in when that you can take advantage when you are using Google Earth Engine with Art. And yeah, in this case, I display number, and this is because the previous result after run EE list size method, it's a number. So yeah, I can easily read the code in comparison to this. Both codes do the same, but here, yeah, I don't have too much information about the type of each of the result of each process. But yeah, both the styles gonna give you the same result. So yeah, you can use whenever that you want. And yeah, there is a lot of more features available in RGE, but unfortunately, we don't have time for explain all of them. We have also extract that it's gonna permit you easily extract time series from image and image collection. Manage that it's gonna permit you manage really in a batch way all your assets. We also have functions to create GIF, and other functions like print to display metadata, monitoring to always see how many times the process are taking in Google Earth Engine, and so on. Where to find more information about Google Earth Engine? Sorry, RGE. And we 3 months ago we published a paper with Professor Christian Wu, Leslie Bautista, Roy Jali, and Anthony Barja. So if you find RGE helpful for your work, we will really appreciate that you cite the paper. The paper is available here. This is the DOI. If you are interested in more information about RGE, we have this website, and here you are gonna find different articles about best practices, considerations, and help with the installation of RGE. And finally, we also have this website, RGE examples, where I think it's a good place to start to use RGE, because we have right now 300 different examples, all of them reproducible. So you just need to copy the examples in your R Studio, and it's gonna work. And you can try to understand what the code does. And yeah, there are a lot of examples, and you can use it for learn about rgee. And just to mention, the next month probably we are gonna um, release the new version of RGE. It's the version is a version 107, and we are gonna try to submit this version to CRAN, this popular repository. And yeah, we was working principally in the unit testing. Thanks to our studio, we also have now a better connection between Python. From the version number 1.4, and we have an additional tool here. If you go here in tools and global options, and after that, go here in Python. Now it's possible to set the Python version that you want to use. So this is something great because now you just need to put here a Python version that have installed the Air Engine Python API, and RGE, it's gonna work. So it's gonna be really, really smoother the installation of RGE in your system. And probably we are gonna deprecate many functions that we implement in RGE to install properly. So yeah, thanks our studio again for that. Some user also ask a lot of questions on GitHub about documentation for how to upload automatically images using Google Cloud Storage. So we are working a lot, and also in try to create some tutorials to help new users to set properly the credential, the Google Cloud Storage credential, that always it's a bit complicated. Yeah, because you need to put your credit card, you need to download the service account keys, and yeah, it's working with Google uh, Google Cloud, and yeah, it's a bit complicated in comparison with Google Drive that everything is automatically. And finally, we are also working a lot. This is probably the most important progress that we did in that we are gonna do in the version 107, that we are gonna be even better the integration between MathView, Layer, and Leaflet. So this is all my presentation, and thank you so much for have the time to listen to me.